Hi guys, I'm going to show you how to do the graphing lab. It's pretty much all online. There's not really anything you need to collect here from the classroom, so should be a simple one for you. First, what you want to do is go to the bulletin board, go down to class documents down here, click on the link, and then open up the class documents folder, which is within that link right there. And then you see labs, open that up, and then you'll see a bunch of labs, but the one that we want is this one called Graphing Analysis Part 1. I'm going to open that. And I'm going to open it with Google Docs. You guys should do the same thing. What you probably should do, because you won't be able to edit this, is make a copy for yourself. So just say File and make a copy, and you can make a copy for yourself, which should work, and you should be able to edit. So first things first, put your name up there. Vocabulary, we talked about this together in the classroom. I just want you to define these words kind of in preparation for doing the lab. Part A is this graph. You have two lines which represent weather balloons. They're going up in altitude, and you can see they're going up in different rates and different ways. What I want you to do is read these questions and analyze this graph and answer those questions. Just put your answers right on the line there. Okay, make sure you label your answers. For numbers 4, 5, 6, and 7, these are math problems. Now, what I had my students do was actually show me their work. It's going to be hard for you to do that. To type it all out. I mean, you can if you want to, but I want to see your answer. I want to see you guys calculate rate of change. And don't forget, you got to label your answer with the units that are proper. So you're calculating the rate of change for balloon A as it goes from 400 up to 800 in the first 4 minutes. So you just got to subtract, right? 800 minus 400 and divide by the time, which is 4 minutes. And that'll give you your answer. Okay, and you're going to do that for all of these questions, 4, 5, 6, and 7. Okay, you'll notice something interesting about numbers 4 and number 6 because we're talking about this line A, and you'll notice there's a constant slope there. That should tell you something. And balloon B, it doesn't have a constant slope. It kind of flattens out here, which means it's slowing down, which means questions number 5 and 7 should be a little bit different. Okay, number 8 is just an answer. Okay, just write that on the line. All right, so part B is a little different for you guys at home. I had a graph here that they were actually plotting this out in class on paper. For you guys, what I want you to do is highlight all of the data here, and then you're going to copy that, so Control C, and then you want to open up Google Sheets. So go back to Google, go to Google Sheets, and we're going to open up a brand new blank document here. And I'm just going to paste my information right into this Google Sheet. So I'm just hitting Control V. And now I have all my data right here. I'm going to highlight all of that, the entire thing, and I'm going to insert a chart. So insert chart, and I'm going to make this right there on the screen. Okay, so there's my graph. That took us a few seconds compared to the kids in class. It took a few minutes to do this by hand. Okay, so here's our graph of sunspots. Now you can immediately see there's a nice cyclical relationship there expressed on the graph. Sunspots are little dark spots that appear on the surface of the sun due to magnetic interference. They tend to be a little bit cooler. They also are the source region for ejections of solar material from the sun, which causes stuff like the aurora borealis here in New York State, which, by the way, just happened to happen here in New York this past weekend and last night. Anyway, so here's the sunspot graph. What you want to do is copy this. So hit the 3 dots there, copy the chart, and you're just going to insert it right in here somewhere. I would say, I'll give you a little room here. Insert chart right here. Okay, insert chart, and you can just paste it in right there. You don't need to link it to your spreadsheet. Just hit paste unlinked. Okay, and it'll show up right there. All right, and then you have some questions to answer about that. So calculate the average time between the maximas and minimas. That means how many years is it from this peak to the next peak. So just count years. And minimas from this little valley here to the next valley, which is right over here. So just count how many years that is. You could look back at the data for that if you needed to. Okay. And then you want to predict into the future. So from this point right here, we want to know when the next maximum would be, because this would kind of extend this way, right? I mean, if I continued this graph, it would look like this, right? Into the future. Okay. So we want to know, when will this next one be over here? That's the question. We know it's this long from here to here. We just figured that out from the previous question. That's number one. Number two is, what year will this happen? Okay, so you're just going to add that many years to this point into the future. And the same is true for here. The next minimum will be what year over here. Okay, and that's just based upon the graph. So you're just adding years to this. All right, number three. Number three is a question about cyclic relationships in nature. I want like four, okay? Four things that are considered cyclical: predictable, changing regularly in a pattern, maybe daily or monthly or yearly or whatever. Okay, a lot of things are cyclical in earth science. Number four and number five are pretty straightforward. Just pick one of these choices from number four. And then there's just some short answer here. Now, it does say show all work. That's kind of tricky for you guys. What you should do is like do this on paper yourself, and then give me the answer here. I don't necessarily have to see all of your work, but I do want to see your answers. Make sure you're doing in rate of change equation. Make sure you always do the final number minus the beginning number, okay, for the top of the equation. The change is always the final minus the initial. So in this case, 400 minus 100, okay? So just be aware of that, and that'll give you the proper units in the end. It's going to be either positive or negative, okay? I think that's pretty much it. When you're all done, you're going to submit this document to Mr. Person, who will take care of the rest, okay? And if you have any questions, don't hesitate to send me an email, okay? Hope you're all doing well. Talk to you soon.